Hi, welcome to Maths Expressions. My name is McLaurin Amechi Maduka, and in today's video, we're going to solve the impossible. Impossible? Yes. In today's video, we'll be looking at area of a segment of a circle. But the question that we're going to solve today is a kind of question that with other ways or other methods, for calculating area of a segment of a circle, you can't use that method to find the area of this segment of the circle with these given values. So before we start, I have a question for you. Is there any way or any method that you can use to calculate the area of this segment of a circle with these given values, which is the arc length and the length of chord, to first of all find the angle of the segment, which is theta, and secondly find the area of the segment? If there is a way you can do that, you are free to skip video. And I would also like to know the method that you can use to solve this question in the comment section. But if not, you can stay with me in this video. Let's do this together. Let's see how we can calculate this question that seems impossible. Okay, so let's get started. The question says segment XYZ has an arc length of 7.24 centimeter and a chord length of 4.38 centimeter and an angle of the segment theta degree. This is the segment is talking about, segment XYZ. And this is the angle of the segment, which is theta degree. This is the arc length, 7.24 centimeter, and this is the chord length, 4.38 centimeter. So question A says, find the angle of the segment, which is theta degree. And question B says, calculate the surface area of the segment using Fredonm's formula. Okay, Fredonm's formula is this formula that we'll be using in our previous video for finding area of a segment of a circle. In case if you are hearing something like this for the first time, we've been using this formula in some of our previous videos to calculate or to find the area of a segment of a circle. But if this is new to you in this video, don't worry. By the end of this video, you will see the formula and you will see how the formula works in action. So let's solve this problem together. Now, solution. So the first question here says that we should find the angle of the segment. So using delta function, yes, delta function. This is a function that we've discussed in one of our previous video. In case if you don't know what it is, you can watch our previous video where we discuss this delta function so that you will see what the function is and what it is used for. Actually, delta function in a nutshell is nothing but a ratio of the chord length to the arc length of a segment. So we just show the relationship between the arc length, the chord length, and the angle of the segment, as you can see here. So using delta function, delta theta is equals to d all over L, where theta is unknown. From this question, we don't know the value of theta. So d is equals to, that's the chord length, d is equals to 4.38 centimeter. Then arc length, the arc length L is equals to 7.24 centimeter. This if you plug in these values, our equation will look like this. Delta theta is equals to 4.38 all over 7.24. So if you do this ratio, delta theta will be equals to 0.6050. It's supposed to be 0.605, but because we did approximation, that's why I added this 0. So if you use the inverse of this function, inverse delta function, theta will be equals to inverse delta function of 0.6050, which will give you 85.58 degree. Let's confirm that with our beautiful calculator. Okay, So this is the inverse function, inverse delta function of 0.6050 close bracket is equals to what? 85.578. If you round it up, if you correct it to two decimal places, it will be 85.58 degree. So that is it, as you can see from our beautiful calculator here. Okay, so therefore theta is equals to 85.58 degree. Now moving forward to question B. Question B says find the area of the segment of the circle using Fredom's formula. Now area of segment x, y, z. Now let's list the given values. The given values say one of them is the length of arc, let's call it L, is equals to 7.24 centimeter. Length of chord D is equals to 4.38 centimeter. And angle of the segment theta, which you've calculated here, is equals to 85.58 degree approximately. Yes. So the surface area of the segment, let's call it S. S is equals to D times open bracket L plus D cos theta all over 4 sine theta close bracket. This formula is called Fredom's formula. Fredom's formula. It is a very unique and powerful formula for calculating area of a segment of a circle, both the major segment of a circle and minor segment of a circle. If you provide this, so far you provide this value, it doesn't care whether it's a major segment or minor segment. It will whether it's a minor segment or major segment, it will still take you straight to the answer, or yes, it will still take you straight to your answer. So this is the formula, and it's called Fredom's formula. So what the next thing we're going to do now is to plug in these values into this formula. And if you do that, S will be equals to this D value for D will be 4.38 times open bracket 7.24 plus 4.38 times cos 85.58 degree all over 4 times sine 85.58 degree close bracket. So if you do this, if you do the calculations, the numerator part will give you 7.5776 all over the denominator part will give you 3.9881. Okay, so that is it. So D here, that is 4.38 times the numerator part all over the denominator part. If you do the calculation, S, that is the surface area of the segment, will be equals to 8.32 centimeter square. And that is the area of this segment you are seeing here. So that's the area of this segment you are seeing here, which looks impossible with this given value before, but as you've seen it here, we have solved for the area of the segment, for the area of this segment you are seeing here. And there's one more thing that I would like you to know. Now you may be wondering, how did I convert this ratio into the angle of the segment? So with this calculator that I've used here, this calculator, it has a function that can convert that ratio, that's the ratio of the arc length, the ratio of the chord length to the arc length. This calculator has a function that is inverse delta function for converting this kind of ratio to the angle of that segment, as we did here. But unfortunately, there is no any other means you can do that apart from this calculator I built here. There's no any other way I have found. And this calculator I built here is for calculating, I built this calculator for the main reason of building this calculator is because of this function you're seeing here, so that we can convert a ratio like this to the angle of the segment. But in the other way around, like finding delta function, if you're watching our previous video, there is other way you can do that. We have a formula for that. But for finding the inverse delta function, there is no formula for that. And there is no any other way I think you can possibly do that. That's why we are working hard, and we have developed math expressions. Math expressions have developed this calculator for the main reason of solving this problem like this. And in non-distance time, our calculator will be made available to the public, where everyone can download the calculator and make use of these amazing features that is being built inside this calculator. And that is it for this video. So if you find this our video helpful, please like our video. It is a prayer for this, it is your prayer and support to this channel. And tell us what you think, or if you have any question or contribution, let us know in the comment section. And also share this video so that it can get to another math lover like you, or any other person that might need this video like this. And I would also like to tell you that in math expressions, this is what we do. We teach new formulas, we teach new theorems, we teach new math tactics for easier understanding of mathematics. We explain everything. We explain everything and make it so simple that it won't be difficult for you to understand, and we make everything plain so that anyone following us will not get stuck along the way. So this is what we do in math expressions. And if you are interested in learning new things, here is a great place for you. Subscribe to Math Expressions channel so that you will always get notified whenever we upload a new video. And that is all I have for you in today's video, and I will be glad to see you in my next video. Have a lovely day or night, depending the time you are watching. Goodbye.